Hello, I'm Dale Leftwich with RealAgriculture. Today I'm with Maurice Maloney, the Chief Executive Officer and the Executive Director of the Global Institute for Food Security. How are you doing today, Maurice?
I'm doing great, Dale. Thank you very much for coming over to visit.
Great. Well, we're here because this is the Biotech Week, and this is the Biotech Week all over the world. So I just thought I'd come and speak to someone who knows a lot about biotechnology.
Well, as you say, it is, and in different parts of the world there are different attitudes to biotechnology. Fortunately, we live in Canada where we're pretty forward-looking.
Right. So one of the things I just wanted to talk about is the fact that we are in Canada and we are in Saskatoon. Saskatoon is kind of becoming a hub for a lot of biotech research. Do you want to just talk about what it is that brings people into the city?
Well, I think, the joke is, of course, the weather, but
of course, yeah.
In reality, the reason we get such great scientists here, I think, is partly infrastructure, and then it's partly the kind of people that we've got clustered around that infrastructure. So just to give you some examples of fantastic infrastructure we've got, you've already made a visit, I think, to the Canadian Light Source.
I did.
That is, a unique installation in Canada, and it can be used for medical purposes, but it can be used for all kinds of agricultural uses. We look at things like nutritional quality in seeds. We can look right through soil and see what the roots are doing inside soil, and we can measure important aspects of growth at even a cellular level with the light source. So that's a very important piece of infrastructure, and we use that extensively in one of our multidisciplinary programs. We also, as part of this sciences cluster, we have a synchrotron on. A cyclotron on campus.
Cyclotron, yes,
cyclotron
yeah.
As well as the synchrotron,
Yes.
and the cyclotron enables us to make short-lived radioisotopes that help us with imaging. Now, people who have ever had medical imaging done, it's the same principle. You take a short-lived radioisotope in a drink, and then it looks at your vascular system and figure out if you've got any blockages in your arteries. Well, in a plant, you can pretty much do the same thing. You can feed similar isotopes to a plant and look at the transport and the functioning at a cellular level inside the plant. So that's an important piece of infrastructure for us. Relatively recently, in the last 2 years, we were very fortunate to win a $37 million grant from the federal government in order to do what we call digital and computational agriculture. Now, once you start to do that, you also build an infrastructure associated with that. People have probably seen quite a few drones flying around over the fields.
Yes.
Well, we have got these AUVs, or autonomous aerial vehicles, that are flying around over the fields, taking pictures of our field trials. And it's a funny thing, but if you think about a plant breeder grows through the field on a regular basis, but doesn't normally have a photocopy of the entire field.
Right, yeah.
So for the first time, these drones are now able to give you a living record. And the secret is, it's not just one photo, it's actually tens of thousands of photographs that we stitch together, so you can see things at an individual plant level. Now, that enables us to help the plant breeder to figure out what's the best accessions that they have in the field and move those into the next generation to make elite germplasm, which ultimately becomes a variety for us.
So I just want to underline a little bit a couple of things you said. One is the Synchrotron, the Canadian Light Source. There's only four light sources like that in all of North America, and I think only 25 in the entire world. So that really does give a piece of hardware, effectively, to Canada, to Saskatoon, to Saskatchewan and Canada, that isn't a commonplace. But the hardware isn't the only thing. As you said, it's the weather, of course. We like the weather here. But you're attracting really great people.
Yeah, so I think obviously to get those people here, you've got to have some kind of infrastructure that's attractive. Then you've also got to have the resources to fund research that's at the cutting edge. You can't do some of these things on a shoestring budget. So, we have been fortunate. GIFS itself was founded on a $50 million donation from Potash Corp and the province. Mm-hmm. In addition, we've brought in a $37 million award from the feds and another $20 million in funding. And that's enabled us really to expand our activities and to be able to go out and get the best people to come and join us here in this endeavor.
Good. So can you sort of mention, say, something that has come out of the research around here that has affected people in Canada and in Western Canada?
Yeah, I think in the three areas that we really focus, which we glibly say seeds, soils, and software.
Right. So it encapsulates them all with three S's, right? Yeah.
There's advances in all of those three areas. The seeds portfolio, we're very interested in the idea that although hybrids have been a major boon to plant agriculture, we really only have hybrids in relatively few crops. Mm-hmm. The major field crop is corn, and here canola. But things like wheat, lentils, soybean, and so on are not hybrids. So we're looking at ways in which we can produce the same effect as a hybrid. Sometimes that's called a hybrid mimic. But basically to find ways that enable us to produce the same kind of vigor without the economic hurdle of having to do the kind of crosses in the field that you can only do with relatively few species. Mm-hmm. So that's one area. Second area is we're looking towards changes in the global climate, and we're going to be affected by that here. Some things will be good, some things will be bad. It'll probably get a bit warmer, right, which is longer growing season, but depending on the annual cycles, it could be very dry or maybe very hot at the wrong part of the year. So we've got to think a little bit about resilience. One of the areas of resilience here is how do you figure out the interaction of roots with the soil and the microorganisms in the soil, because that is kind of the foundation of how a plant is going to survive any of these stresses. Right. So since we brought on board our colleague Leon Kochian from Cornell University, so there's an internationally renowned scientist that we brought into Saskatoon, he's looking at root architecture, root activity in the soil, the ability of roots to recruit the help of microorganisms in the soil, all about this resilience phenomenon. And ultimately we'll develop varieties with the breeders that are more capable of withstanding some of these climatic ups and downs. It's a funny thing, although it could be hotter and drier in some years, we also recognize that we're going to have more rainfall at certain times of the year, which could be flooding. Yeah. So again, roots need to be able to adapt even to flooding situations. So all of those are underway. And we've developed this digital agriculture portfolio because it became more and more clear to us that IT and agronomy and genetics now overlap. Right, yeah. Now, how can we improve what we do with IT? Well, I think a lot of it is augmenting the breeder's eye. So the breeder has both observation and intuition, and we need to learn how to enhance those things. And some of those things are done by using, for example, different types of radiation to take a photograph. Everybody's seen the commandos with night vision goggles, where they're looking at infrared images. Well, we can't normally see infrared, but if you look at a plant and look at its infrared profile, it tells you a lot about how rapidly it is transpiring, which is another measure of how well it is photosynthesizing. In other words, how well it's going to grow. So this is the kind of novel technology that we will use in order to get data, large-scale data, that will then feed back both to the breeders on one side and, in fact, to the farmers on the other.
So those will have impacts in Canada and in North America. You also are involved as a Global Institute for Food Security around the world. Can you outline a couple of things that you've worked on in other parts of the world that also to help feed the world?
Yeah. So one of the pieces of philosophy that we have at GIFS is that if we do discover something that we think is important for agriculture, we try and find a way of making that transferable to developing world agriculture. Now, sometimes that means you've got to simplify it and strip away a lot of the high-tech stuff. Sometimes it simply means you've got to make it more robust in the hands of people who are non-specialists. But we had a conference here in the summer where we had representation from, I think, 8 or 9 African countries. It was a fantastic opportunity to listen to what the needs are and see how our technological developments and our research would actually fit into that. I'll give you one example because it's an ongoing project here at the university, and that is with Carol Henry's group over in Pharmacy and Nutrition, and they have been developing the humble chickpea in Ethiopia.
Oh, yeah, yeah.
Now, it's a beautiful story because in Ethiopia, between the growing season of their major cereal, they had about a 4-month gap in which they weren't growing anything.
Okay.
And we introduced chickpea into that as what we call a shoulder crop. It just fills in the gap. And now you've got a protein crop growing there that's fixing nitrogen, enriching the soil. And then Carol's group invoked a whole bunch of nutritionists to figure out ways in which you could actually enhance the use of chickpeas in the diet there. Anyway,
kind of a biofortification?
Biofortification,
okay, sure.
increased protein intake for kids and so on.
Okay.
And they've been monitoring this, and they've already seen improvements in problems like stunting in southern Ethiopia as a result of this. So I think, you start out with the genetics of the chickpea.
Right.
You have to figure out the microorganisms that help to fix the nitrogen, which we have inoculants here, but of course they have to develop all those things themselves.
Right.
Get the agronomy right, get the food processing and the nutrition right, and there's a whole story there. And it's worked so well that even if Canadians just step back from that, it carries on.
Oh, good.
So that, to me, is a success story. And we mentioned it, I think, in our annual report that was published a few months ago.
Okay. Well, Maurice, I really want to thank you for being with us at Real Agriculture today. You've talked a little bit about the different kind of science that's out there. So happy Biotech Week, Maurice.
Well, thank you very much, Dale.